Let's define a function named add, and we will have parameters named n1 and n2, and we will return n1 plus n2. Let's make a result variable. Result equals add. Let's take the argument as 50 and 16. Now I'm going to print the result. So when I print it, I'm getting the output as 110. So what this function is doing? So we have two parameters n1 and n2. It is returning n1 plus n2. So when we call the function, it will add n1 and n2 and store it in result, and we finally print the result. So function are blocks of code which can be executed multiple times without needing to rewrite it. So let's make another function named dot check, and here we are taking string. Now let's make if statement. If dog in my string dot lower method, then we'll return true, else we will return false. Let's print dog underscore check, and let's put the string as my dog ran away. When we run it, I am getting the output as true. Okay, so now let's make it in a small way. Let's make it like this: dog underscore check, and then let me make the same my string as the argument, and here we will just return dog, and then in my string dot lower method. So again we'll print my dog ran away. So you can see it is giving the output as my dog ran away because I have not put the function check. Let me put here. So you can see here it is giving true. So the line of code is decreased in this approach. So now let's see about recursion. So recursion is a function which can call itself. So let's do factorial. So factorial underscore recursive. Let's make the argument as n. So here I am going to make if statement. If n equals 0, then or n equals 1, we will return 1, else we will just return the factorial. Return factorial of, let's say, n into factorial of n minus 1. Okay, n minus 1. So now let's print, let's say factorial recursive of 0. Let's print another one, factorial recursive of, let's say, 5. So you can see the output as 1 and 120 because factorial of 0 is 1 and factorial of 5 is 120.